a bunch of people in class, so I didn't know. I didn't know it was me.
It's
But
him, and there's another one as well. There's another one as well. I know the voice. I just can't recall the names because remember when I'm teaching, I can't see your names.
so, ma'am, yes, you was asking about the trig, ma'am.
Yes.
Ma'am, actually, trig, can you please go deeper, ma'am? Your trig is very difficult, especially the shifting and the vertexes, the amplitudes, those kind of things, ma'am. I've been trying to. It's very difficult. So please, ma'am, can you just go deeper for me? That's, ma'am.
Okay. So let me see if I'm recording. I think I am recording. You're sharing your screen. Yeah, I think it's recording. So let's start. My what I've noticed is stop. Okay, it's recording. So what I've noticed is, ne, if you start on the place where you don't know your basics in mathematics, it becomes difficult. Everything becomes difficult. That is why Euclidean is difficult for grade 12s because it then starts in grade 9 with a point, then a straight line, then parallel lines, then perpendicular lines, then what's this vertical opposite one, because they don't remember their basics. So if you then start with your basics, then it becomes much better for you to understand trigonometric function. So in chapter 5, they say we're looking at trigonometric functions, but then we'll start with a unit circle approach. Right? Now, does anyone know the unit circle? What a unit circle is? Guys? Does anyone know what a unit circle is? Yes or no?
Yes,
Hi,
ma'am.
ma'am. Okay, go ahead.
I'm not gonna lie, ma'am. I don't know what a
Okay.
unit circle is.
So who thinks they know? Okay, so in this word, what is a circle?
I think it's just a sphere shape. And when we're talking about unit circles, think like we're talking about the circle that has a radius of 1, since 1 means unit. I think that.
Yes, you're right. So a unit circle is basically a circle with radius 1. That's a unit circle. And when it comes to trigonometric, it's very important, right? So the objectives are the unit circle, the terminal points on the unit circle, and the reference number. I think we are going to cover some of the questions in chapter. What's this? In assignment 1. I think it's the first question. So now the unit circle. Do you guys have calculators next to you? I'm giving you permission today because I want you to see something.
Yes, ma'am.
Yes, so make sure you have calculators. And then we can start. How many people have calculators? Say 1, 2, 3, at least.
1.
1.
Two.
Okay. So
3.
we have so we have 3 people who have calculators. So now if you look at your calculator on top, is it written what? R or D?
D.
D. So if you say sine 2,5, what do you get?
5/2.
And that's wrong according to so that's not right according to, I'm also looking for my calculator. Where's my pen? Okay, give me a few seconds, ne? I just want to look at for my calculator. I can't find my Casio calculator. This one, the sharp one, is giving me difficulty. Okay. Now you get 5/2, right? Because at the top it's written D. Are you able to change it into R? Wait, radians.
In the radians. Okay, let me try.
Isn't radians, ma'am? Mine
Yes.
is in radians.
How many people can change it into radians? Let's see. Because then, for as much as you don't know how to use, oh, there's my calculator. So mine is on R already. So for as much as you don't know how, you're not going to use calculators, but I need to make sure that you understand how to change it into radians and degrees. Have you changed it into radians?
Yes,
Yes.
ma'am.
So if you say
Yes,
sine
ma'am.
2,5, what do you get?
Sine
You
what?
say what?
2,5.
Ma'am,
Yes.
sine 2,5. Can
Mm.
you please repeat again? I'm lost.
Okay. So you see when you open your calculator, what calculator do you have? It's a Sharp. I hope it's a K-Show calculator.
Okay, sure.
Yes. So on top there, when you open, there's an M and there should be a D between there. Do you see that?
Yes.
And if you say sine 30, when you start, okay, let me change it to a D, which is degrees. So if you say sine 30, what do you get? 30%. You get what? 1/2, isn't it?
Yes.
But then if you change it to R, where there's D, you say shift mode setup, and then you go to red for radians. If you say sine 30, what do you get?
I'm getting a negative 0,98.
Yes. So it means that in our work, we'll be working with radiances, right? Now, if your calculator is obviously because you're not using a calculator, but then if you were using a calculator, you were supposed to every time change into an R on top of there on your K-Show calculator. Does that make sense?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Yes, ma'am.
So now we can continue with
Yes.
unit circles. So they say the unit circle. In this section, we explore some properties of a circle of radius 1 centered at the origin. Now, they say the set of points at the distance 1 from the origin is a circle of radius, meaning that when you move from here to there, the distance is 1. From here to here, it's 1. That's the radius. Here to there, here to there. That's a radius of 1. That's equals to R equals to 1. And if a circle has a radius of 1 and it's from the center, this is called the unit circle. Are we all together there?
Yes.
Yes, ma'am.
Yes.
Yes,
Now let's say the equation of this circle is x squared plus y squared is equals to 1. Now they say the unit circle is a circle of radius 1 centered at the origin in the xy plane. Its equation is given by x squared plus y squared is equals to 1. Now, a question might pop up and say, you have this point, given this point, right? Show that this point is on the unit circle. What do you think you'll do? If I say in the exam, show that this point is on the unit circle. What do you think you will do? You can guess.
I think we're gonna change them to radians.
But remember, you only change the degrees into radians, not the points.
I think we
Ma'am,
put them in the equation.
don't you just
I'm thinking.
and see
Okay,
if they
let's
can
hear
give us
Tabang.
one.
Guys, let's hear Tabang. Tabang is saying something.
don't you just plot it on the graph because the distance on the x-axis is the same as the one on the y-axis?
Mm-mm.
Okay.
Ma'am, don't you, because you're given 2 points, don't you find the radius first and then plot it using after finding the radius, and then you find actually, I don't know what to put it, but firstly find the radius.
Okay, that's okay. Okay, let someone help thee, not find the radius.
I think you give us
Stacy,
x squared.
okay. sorry, Brenda. Brenda, may I please make you the presenter so that you can be able to help the others to enter, because it's distracting me really.
No problem.
Make you presenter. Specie and Euler, please don't raise your hands, guys. You can say something so you guys will give each other chances, because I can't see hands on my side. Like right now, I can see them because I'm here, but I can't see them when I'm teaching. Specie, let's then Euler, you come after. Yes. What do you think we'll do?
Ma'am, don't we put them in the equation and then add, and if they give us 1, then they are the unit of the circle?
Thank you. So look at this. You are given an XY value. You come and substitute in here and do what these value this. So you have the X value, you say X squared plus Y squared. If they give you 1, then that point is in the unit circle. So here they say that show that this point is in the unit circle. In the exam, I might say, which of the following points is in the unit circle? Are we all together? So we know that the equation of a unit circle is X squared plus Y squared is equals to 1. Meaning that for us to show that it's in the unit circle, we know this is a point, and a point consists of X and also consists of Y. So meaning that we'll go and say X squared, we want to prove this. So then we'll say X squared plus Y squared is equals to the square root of 3 over 3 squared plus the square root of 6 over 3 squared. And we know, according to our exponential laws, if we have A over B squared, this is the same as A squared over B squared. So meaning that this is equals to the square root of 3 squared over 3 squared plus the square root of 6 squared over 3 squared. And according to our exponential law, if you have the square root of x times the square root of x, this is the same as x. And also, because we know that the square root of x is the same as x to the power of 1 over 2. And if you square the square root of x, this is the same as the x to the power of 1 over 2 to the power of 2. 2 times 2 is equals to 1. Therefore, this is x to the power of 1, which is just equals to x. Meaning that if you square this one, the square root of 3, it will just become 3 over 9 plus 6 over 9. So then this is equals to, because the denominators are the same, you take the denominator the way it is, and then you add the numerator. So this is 3 plus 6, which is equals to 9 over 9, which is equals to 1. Therefore, since this is equals to 1, therefore this point is on the unit circle. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes.
Yes.
Thank you. So I think here they say, okay, we need to show that this point satisfies the equation of the unit circle. That's what we did. We substituted and got 1. Now, the terminal points on the unit circle. So now, okay, let me just go. Suppose t is a real number, meaning t is a value. You know what are real numbers. So they say if t is greater than or equals to 0. Is someone saying anything or a question, guys? If I'm moving very fast on, please ask, because I don't want us to miss this point, because all the work will be built up from what we are learning. Suppose t is a real number. Now they say if t is greater or equals to 0, that means that t is a positive number or is equals to 0. Let's mark off a distance t along the unit circle. So meaning that at this point, because we're dealing with the unit circle, we will be moving on top of the unit circle like this. That whole blue part will be moving on top of there. Are we all together?
Yes, ma'am.
Thank you.
Yes.
Now they say if t is greater than 0, let's mark off the distance t along the unit circle, starting at a point 0 and 1. Meaning we're starting at this point here. It's 0, it's 1 and 0, this point here. That's where we'll be starting every time we move. Are we together? Now, when they say moving in a counterclockwise direction, in high school, we used to say in the anti-clockwise direction. You know your watch moves like tap, 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 unless, I don't know, even a Versace moves like that, unless yours is something else. So a clock moves in this direction. And in our trigonometry, when it comes to trigonometry, not in our, but when it comes to trigonometry, we move like this. This is the positive direction. Are we all together? In the opposite direction of the watch, that's why they say counterclockwise or anti-clockwise, right? So it means that your t, your distance t, is greater or equals to 0. It means that if your t is positive, you are moving in this direction. Are we together there, guys?
Yes, ma'am.
Thank you.
Yes.
Now, if your t is less than 0, then you are moving a distance of the absolute value of t. What they mean is, let's say t is equals to negative 30 degrees. It means that you are moving 30 degrees in the clockwise direction. Are we all together?
It makes sense, ma'am, but can you please explain it again, ma'am?
Which part?
The anti-clockwise and the anti-clockwise and I don't know, ma'am.
Okay, so your clock, your watch, you know it moves like this, isn't it?
Yes,
That
ma'am.
one, it moves like this, right?
Yes, ma'am.
That is a clockwise direction. They're referring to your watch, actually. They're saying clockwise because it's a clock, right?
Yes, ma'am.
Now, in high school, you say anti-clockwise, meaning, for example, someone is against something, they are anti-whatever, right? So, meaning if they are anti-clockwise, it means that they are not moving, they are opposing the direction of the clock. They are moving like this. Do you see that?
Yes,
So
ma'am.
that's the anti-clockwise. Or in our study, in our slides, they call it the counterclockwise. Yeah? Now, in trigonometry, you always move anti-clockwise like this. Okay, the first one will show you. You see the arrow, the first one shows. It means that if you are moving, if your t, that's your distance, right? If your t is positive, let's say t is equals to 30 degrees. I'm using degrees right now because I haven't explained the part of radians. Are we together? Now, we know that if t is 30 degrees, we know that 30 degrees is somewhere here. So meaning that you are moving along this unit circle, but you are here. So, but you are moving this direction. So that's t 30 degrees. Are we all together there?
Yes, ma'am.
Now, if t is
Yes, ma'am.
negative 30, it means you are moving in the opposite, meaning that you start from here and then you are moving down there. That's your 30. Your 30 will be somewhere here. So this will be 30 degrees. Are we all together there?
Yes.
Can I move on now? Guys?
Also, t is the distance. Okay.
Yes, t is the distance. When the t is positive, let's say positive 30 degrees, they are telling you that it's moving. Remember, it's moving, especially when you're looking at a pie. Remember your pie. Remember when you're doing pies in data handling, the pies were in degrees. When you're taking a slice of pie, isn't that when you're moving along the circuit, you're taking the slice of pie?
Yes.
And they say these are houses, therefore they consist of 30 degrees. These are sharks, therefore they consist of how many degrees? You were taking that. So the distance from here, that's the t. From the unit circle to this point here, which we call it the terminal point, that's the t, the distance. If your t is negative, meaning that now you're no longer moving up, but you're moving down.
Moving down. Okay.
Yes. Same distance, which is moving down. So meaning this pi over here and this pi over here, this pi over here and this pi, they are the same. It's just you're moving in the opposite direction because of the negative t. Make senses or not?
It does,
That's
ma'am.
So that's why they
It
say
does.
here,
Makes sense.
when t is negative, meaning that t is negative 30, we mark off a positive t, the distance 30 degrees. You are moving, you can't say I'm moving a distance of a negative 30 degrees. This is only showing you a direction, but your distance will be 30 degrees in the clockwise direction. Are we together there? Yes or no? Can I move
Yes,
on?
You can move on, ma'am.
Yes.
Now they say, in this way, we arrive at a point. So meaning that when we move along that unit circle, remember, you can't just move and say so that when someone you ask where are you, you say I'm at this point. When you are moving in a car, they ask you, don't be like me because you don't know where you are because you sleep when you're in a car, and when they ask you, you don't know. You tell them I am at this point. Isn't that when you are moving, you say I am at wherever midrand, and you move and get to a point. So on a unit circle, when you move, or on a circle, let's say in this case, because we're looking at a unit circle. So when you are on a unit circle, you move on the blue part. You will never move outside the unit circle, guys. You'll always move on the blue part, and wherever you land, that point, we'll call it a terminal point. And in most cases here, they gave it a P. Are we all together?
Yes.
So they say in this way, we
Yes, ma'am.
arrive at the point. And remember that point has an x and y value on the unit circle. The point P, xy, right, which has a coordinate of xy, obtained in this way is called the terminal point, determined by the real number t. That's why in your assignment it says determine a point turning point P determined by the values of t, and they say t is equals to pi over 2, pi over 6, and pi over what. Are we all together?
Yes.
Yes, ma'am.
So the reason why they say
Yes,
determined by that, they are saying to you t is equals to pi over 2. Give me a terminal point that you will end at when you move pi over 2 distance, a distance of pi over 2. Where are you going to end? When you are moving on the circle on a distance of negative pi over 2, where are you ending? That's what they are asking you, especially in the first place. Are we all together? So let's continue.
Can you
In this
explain again, ma'am?
Okay, now because they give you a t, and remember a t is the distance, right? So they are saying that if t is equals to pi over 2, let's say they say give me a terminal point determined by t, they say t over 2. They're saying give me where you will land after moving pi over 2 distance. Okay, let's say t is equals to maybe 90. Where are you going to land? You know here it's 0, you know here it's 90 degrees. So if you are moving here, okay, if you are moving 90 degrees, it means you land at here. And we know this point is what? We know this point is 0 and 1.
0 and 1.
Thank you. So that's what they're asking. That P that they're asking you XY determined by T. It's the point that you obtain after moving a distance of T. Are we all together?
Yes, ma'am.
Thank you. Now they say the circumference of the unit circle is 2 pi times 1 is equals to 2 pi. Now look at this. Remember the circumference, do you remember what a circumference is before I talk about the circumference of a circle? Guys? Do you remember the circumference? If you measure the whole distance here, that is the circumference. That's 360, right? That's 360. Now, we know that the circumference of a circle is 2 pi r. And in this case, we know our pi is what? Our r is what? Is 1, isn't it? Because it's a unit circle. Therefore, our circumference is 2 pi, the radius 1, which is equals to 2 pi. So meaning that for a unit circle, the circumference is 2 pi. Are you all together?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So now they're saying the circumference of the unit circle is equals to 2 pi r, which is guys, it's echoing. Okay, the circumference of the unit circle is c is equals to 2 pi r, where our r is 1. So times 1 is equals to pi. So if a point starts at 1, 0 and moves counterclockwise all the way around the unit circle, it returns to 1, 0. It travels a distance of 2 pi. Does that make sense?
Yes.
Okay.
Yes, ma'am.
So now they say that to move half around the
Sorry, ma'am.
circle.
I
Yes.
don't quite understand what they mean. There by
Okay.
the counterclockwise, yeah.
So they're saying that this, you see, this is a circle. Can you see my circle? My unit circle, right?
Yeah.
So that unit circle, we know this point over here, this is 1 and 0. And this is 0 and 1. And this is negative 1 and 0. And this one over here, we know it's 0 and negative 1. They're saying that because the circumference is 2 pi, right? Which is 360. Let's write it 360. Ne?
Okay.
They say if you're going to move 360 degrees, you know that when you move 360, isn't that you're moving all around the circle? You will end up at that point again.
Yeah.
That's what they're saying.
Oh, okay.
So in radians, 2 pi is 360 degrees.
Oh,
I'll show
okay.
you that later on. Yes. So when they're saying 2 pi, they're just saying moving 360 degrees. So this statement is saying that if I start at this point and I have to move counterclockwise, meaning that in this direction, I'll come back to that point because then I know that if I come back to that point, I've moved a distance of 2 pi. That is a distance of 360.
Okay.
So now they say to move half of the distance, meaning that if I draw a circle here, half of the distance, I'm moving from here to there. What is half of the distance in degrees?
1 pi.
I mean, yes, 1 pi. But then in degrees, it's what?
180.
Yes. So this is 180 degrees. So that is the pi. So 180 degrees is pi in radians.
Oh,
Are we
okay.
all together? Yes.
Yeah.
So I'll show you that now. Now to move a quarter of a distance, meaning that you're moving, if you move a quarter of 360, what is it?
It's 90, ma'am.
Yeah.
Yes, so meaning that you are here, it's 90 degrees, right? Then in here, it's called pi over 2 in radians. So they say, where does the point end up when it travels these distances along the circle? From figure 3, we see, for example, that when it travels a distance of pi, right? It means this is one, it travels a distance of pi. It's from here to there. Okay, I think I'm not doing it correctly. I'm not doing it correctly. I'm not doing it justice here. Let's start here, right? So now, remember we had, because I think I might confuse people with these radians. Do you know how to change degrees into radians? Let's start there.
No. No,
Can you?
ma'am.
Yes, I just need to answer this one.
Guys, while you still waiting for mem, can you try to convert angles to radians? I think we multiply it by pi over 180 to convert it into
Yes.
radians.
Yes, it is pi over 180. I learned
let's
that
say we're-
on the next 1511 class.
Oh yeah, with Mr. Malaj. Okay, so say you're given 90 degrees, you want to change it into radians. You can just say 90 times pi over 180. So 90 will multiply pi, or you can do the cross multiplication. And then you'll be left with what? Pi over 4.
Can you repeat again?
If you want to change angles to radians, let's say you are given 90 degrees, right? You want to change it into radians, you just multiply it by pi over 180. So 90 degrees is just like 90 over 1. Pardon?
You multiply 90 by pi over 180.
Yeah, just saying the angle you're given is maybe 90, 30, 255, whatever angle you're given. To change it into radians, you have to multiply it by pi over 180.
Okay.
Then you just reduce it into lowest term if you can. And now we end up having pi over 6, pi over 4, 5 pi over 3, like something like that.
Guys, I don't know where I put my pen. I'm coming. Change. I want you to change 30 degrees, all the special angles. 30 degrees, 60 degrees, 45 degrees, 90 degrees, 180 degrees, 275 degrees, and 360 degrees. Did you hear the degrees that I want you to change?
Yes.
Yes.
Should I repeat them so that you write them down, then we can continue?
Yes,
I
please,
think
ma'am.
the segments on the unit cycle that just gave us.
I want you to change them into radians because we're dealing with radians. I want you to change 30 degrees, 60 degrees, 45 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Those are special angles that you need to know by heart. I want you to change those ones.
Well, ma'am, for 30 degrees, it is pi over 6.
Okay. So let's write it down. That's why I'm saying I'm not doing justice by going straight to the things. So we're saying for 30 degrees is what? Pi over
It's
6,
pi over
right?
6.
And then for 45 degrees?
Pi over 4.
Pi
Thank
over
you.
4.
Pi over 4. And then for 60 degrees?
Pi over 3.
Pi over 3. And then for 90 degrees?
Pi over 2. Pi over 2.
Pi over 2. And then for 180 degrees?
Pi.
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 Thank you. And then for 270 degrees?
3 over 2. 3 over 2. 3 pi over 2.
Thank you. And then for 360 degrees?
2 pi.
Thank you. That's 2 pi. So how do we do that? What we said, if we take the degrees, so let's say 30 degrees, we multiply the pi over 180 degrees. Remember, I don't want you to use a calculator. So this is the 30 degrees times pi over 180 degrees. And you ask yourself, how many 30s are in 180? There are 6. So this is pi over 6. Are we all together there?
Yes, ma'am. Yes, ma'am.
Thank you. So that's how
Ma'am.
you then find those what's this? Those now are we together on the radians, right?
Yes, ma'am.
Yes, ma'am.
Thank
Yes,
you. So
ma'am.
now we can go to the slides, and then if there's something else, I'll come back. Now we can go to the side. I think now it will make more sense. So they're saying, where does the point end up when it travels these distances along the unit circle? Figure 3, we see, for example, that when it travels a distance of pi is what, guys? What is pi? In degrees.
108.
Thank you. It means it comes here, 180 degrees. So it means that in the unit circle, it would have traveled like this and ends up here. This is the one. Do you see that? Now, when it has traveled pi over 2, what is pi over 2? 90 degrees. It's this one. When it travels 3 pi over 2, this is 270 degrees. And when it travels 2 pi, it means it went around. This is 360 degrees. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I'm waiting for a call, but find the terminal point on the unit circle determined by each real number t. Can we try discussing that before I come with things that are not part of the slides?
Yes, please.
Right? Can we discuss this part? I don't like when I open the slides, it gives you answers. Find the terminal point on the unit circle. Let's discuss that.
We want the point where t, which means the distance of 3 pi.
Well,
Ma'am, isn't it on the
It's gonna be
opposite
minus
end?
1 and 0. It's gonna be 3
Yeah.
times. Yeah, so it's gonna be complete 1 and another 1. So it's gonna be on the negative 1 0 point.
Isn't it a 360 and a 180 together?
Yeah, and at 180.
I like how you guys thinking now. Do you see that when you understand the radiances, it becomes easier for you to understand how to find the terminal point?
Yep.
Yes, ma'am.
Is there anyone who has a problem there? Should I explain it?
Yeah, ma'am, can we explain it?
Okay. So remember, we were moving. Let's start here on our unit circle, né? Because we are working with radiances, we'll talk radiances degrees. I don't know if that's a good statement. What Brenda and who was also speaking there, I think I need to know the names now. Who was the gentleman speaking?
It was me, Tabang.
Brenda and Tabang are saying that we moved 360 degrees and then we moved another 180. It's because we know this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees, and this is 360 degrees. Are we all together? Are we all together?
Yes, ma'am.
Yes,
Now we
ma'am.
know that from here we change it. 0 degrees is this 0 is 0. 0 is 0, guys. Whether it's in degrees or radians, it's 0. So it means it's 0 there. Now, our 90 degrees in radians, we said it's what? Pi over 2, isn't it? Our 180 degrees, we said it's pi, isn't it? Our 270, we said this is what? This is 3 pi over 2. Thank you. And then here we said this is 2 pi. Are we all together?
Yes, ma'am.
Yes, ma'am.
Now, they want us to move 3 pi. According to our, remember we're moving on the unit circle, so it's important for us to draw a unit circle. It might not look good. I'm not an artist. I do not know how to draw. I am not good. So let's assume this is a unit circle. We know on a unit circle, this point here is 1 and 0. This point here. This point here is what? This is 0 and 1. This point here is negative 1 and 0. And this point here is what? It's 0 and -1.
The -1.
And every time when you move, you start here. This is where you start. Do you see that? My issue is that we're always using one color here. I don't know. Let me see. Can I change it? Oh yes, I can change colors on the slides. Okay, thank you. We're on this point here. Finally, I learned something. You see where we start? Always here. Can I answer that, guys? I do apologize. Let's answer that fast. It's not the car. It's not the car, but I'm deleting this. People are disturbing me today, but let me explain this one quickly. So we have our unit circle. Right? So this is 0, pi over 2, pi, 3 pi over 2. Yeah, people are disturbing me today. Please, I apologize. So the pen, how? Now I was able to change what happened? Okay, I'm failing to change now. I changed the color. So I changed into this one. So we said this point over here, this is 1 and 0. This is 0 and 1. This is 0 and -1. And this is 0 and, this is -1 and 0. And this is 0 and -1. So we always start at 1 and 0 because t is positive. So we then say, okay, fine. We know 2 pi, like for example, 2 pi. We're moving straight around like this. We point through these points and we come back there, right? Now, because it's 3 pi, it means you added another pi. So it means you start here again and you move. What did I do now? You start here again and then you move. You'll end up there. Does it make sense, guys? Yes or no?
Yes, ma'am. Yes,
so
ma'am.
The terminal point
Yes, ma'am.
by this xy, this terminal point will be what? Will be -1 and 0. Are we all together?
Yes, ma'am. Yes, ma'am.
Can someone guess the terminal point determined by negative pi?
We're gonna move in an anti-clockwise, and then we're gonna end up at -1 and 0 at 180.
Okay.
Yes.
Please repeat what you said.
I said we're gonna move in an anti-clockwise, like from 1 and 0, and then move down there to -1 and 0 on 180. That's where we're gonna end.
In clockwise on anti-clockwise.
Anti-clockwise.
Can we fix that?
It's not clockwise.
No,
We move
sorry.
clockwise.
Why clockwise? Let's fix that.
Because when it's minus, we move to
Because
the white
that
side.
is minus.
Thank you. You might get the right answer, but if I say give a reason why are you moving clockwise or anti-clockwise, you might get it wrong. Because of the negative here, it means we are moving clockwise direction. So here it should be. I don't like being disturbed when I'm teaching because then my mind does something else. Okay? But my apologies, don't worry, we'll be fine. Okay, I don't know why my pen is doing this. So because of the negative here, it means we start here and move pi. Where does the pi is? Where is pi? So it means that in this
180.
Thank you. So it means you are moving like this. So meaning that your terminal point here will be what? -1 and 0.
-1 and 0.
Thank you. And then here, what is our terminal point here? It's C.
0 and
This is-
-1.
Yeah.
Thank you.
-1.
It means we're on the same page, ne?
Yes, ma'am.
Is anyone who has a problem thus far? Guys, are we all okay with terminal points, isn't it?
Deb,
Yes,
Deb,
I'm okay.
can you
What?
explain?
The what?
Can you explain? I don't understand.
I can't hear you.
The 3 pi.
Can I explain the 3 pi? That's what you're saying.
The 3 pi is equals to 2 plus pi. I want to understand how.
Okay.
How you got this pi?
Okay. Isn't that 3 pi is the same as pi plus pi plus pi? This is equals to 3 pi, right?
Yes.
So I know if I move from here, this is pi over 2. Pi over 2 plus another pi over 2. This is pi, right? This is pi. So this is the first pi. If I move from here and come back here, this is another pi. If I move from here again and come back again here, this is another pi. So that's 3 pi.
Yeah.
That's how I move.
Okay.
Yes. Okay. So let's see the answers, what they're saying. They're saying that from figure 4, we get the following. So we started here, we moved all around. Do you see that? All around, and we came back to that point. Do you see that, guys? And then for negative pi, we moved from this direction, and we were there. And negative pi over 2, we got there because of the negative. So the arrows are showing you because of the negative, we're moving like this. But because of the positive, we'll move like this. Yeah. So this is the call I'm expecting. I'll answer now, and come back.
So wait, guys. I want to understand the direction thing in terms of the terminal point. So when we are talking of a terminal point, that negative or a positive describes the direction in which we are going to take or for us to reach that point that we want.
Yes.
Yes.
So it's just like the same way you do the shifting of the graph, like when you're graphing things and you say negative, you must pulling it to the right or to the left. It's the same thing that you're doing on pi.
Okay, I think I was because on that B part it was like the T was negative pi, but I was thinking to myself, how am I gonna get there using the unit circle? And then I'm like, oh, okay, because of that negative, I'm starting from 0 to 70 to 180. And then yeah. Okay, cool. Thank you guys.
No problem. When it's just negative, you have to know that instead of on the unit circle, we go anti-clockwise, right? So that is when it is positive. When it becomes negative, you just know that you are reversing. So now on the when it's negative, you have to move like the way the clock moves, like clockwise. But the other thing is just to be tricky is yeah, from pi, when it's negative, you just in reverse. So you have to know which angle matches with which one. So if it's 30 there on the bottom side, which angle does it moves? So does it matches with? That is another also thing that can help you to just memorize it.
What I also sometimes do is I number the quadrants so that I know based on how the quadrants progress, I know I'm going in a positive direction or a negative direction.
Yeah, that's another thing. Yeah, it's a cool one actually.
Yeah, now I'm back 100%. Okay. I'm not talking to myself next.
No, ma'am.
Yes.
Yes. To us.
No.
Is your business done now?
Yo, it's done. And I don't like being disturbed when I'm teaching because they remove me out of the mood. So now they say the terminal point determined by 3 pi is negative 1 and 0. Yippee to us, we got it. The terminal point determined by negative pi is negative 1 and 0. We got it. And then the terminal point determined by negative pi over 2 is 0 and 1. Negative 1. We got it. Well done to us. Notice that different values of t can determine the same terminal point, such as this one and that one. Now they're saying the terminal point xy determined by pi over 4 is the same distance from 1 to 0 as from 0 to 1 along the unit circle. Does that statement make sense? I know there might be a no.
No, man.
It's
No,
because,
ma'am.
it's because when I read it at first, I was like, huh? Okay. So they're saying that the terminal point determined by pi over 2, right? Meaning that, remember, pi over 2 is half of this one, 90 degrees. It's there. Do you see that? That terminal point, xy. Ne? Guys? Are we
Yes,
all
ma'am.
together?
Yes.
So they're
Yes,
saying
ma'am.
the terminal point determined by pi over 2 is the same distance from, so meaning it's the same distance from this point here, which is 1 and 0. So this distance to this point and this distance to this point are the same. That's what the statement is saying.
Okay, ma'am.
Yeah.
Don't they mean because the radius is the same, that means we can find any point on the circumference, ma'am?
No. On this particular one, they are saying that, remember, if we go back to our high school, we know this is 0 and this is 90. You know, 45 is the half of what? Of 90. 45 degrees is the half of 90. Because when you say 45 plus 45 gives you 90 degrees, isn't it?
Yes, ma'am.
So they are saying that the distance from the point on the unit circle, which is 1 and 0, the distance from here to that terminal point there is the same as, is the same as the distance from here to there, to that point there. That's what they are saying in the slide.
Yeah, I think you can also say since it's distance, you can use the absolute value rules where say, even though you are going to the opposite direction, everything in the like if it's negative, you know that you can only have a positive absolute value.
Yes. So meaning that from the red part is the same as the here, moving from this point to that point. So this distance and this distance are the same. Are we all together there?
Yes, ma'am.
Thank you.
Yes, ma'am.
Yes, ma'am.
Now they're saying that since the unit circle is symmetric with respect to the line y is equals to x, it follows that P lies on the line y is equals to x. Okay, I'm tempering myself not to talk about this thing. Let me not talk about it. Yeah. Did you understand that statement? And
No,
guys,
ma'am.
No, ma'am. No,
so
ma'am.
they are saying that the unit circle. Okay, let me just talk. Let me not. When you are reflecting about the x-axis, what are you getting in functions?
A mirror.
Y is equals to x. What are you getting when you're reflecting about the line y is equals to x?
An inverse.
Thank you. So let's not talk about it because I'll end up talking too much. Now, this line here, right? This line here is the line y is equals to x, right? Now they're saying that the circle is symmetric, meaning this half over here, the top half here, when folded this side is exactly the same as this half there. That's what they're saying, that the unit circle or this circle is what? It is symmetric about this line y is equals to x. That's what they're saying. Are we all together there?
Yes, together, ma'am.
So now they say since the unit circle is symmetric with respect to the line y is equals to x, it follows that P lies on the line y is equals to x. Okay, so if P is the point of intersection, meaning that in the quadrant, they're showing here that point P is a point of intersection of the red circle and this line. Do you see that? Guys?
Yes, ma'am. We see.
So
Yes,
P
ma'am.
Yes, ma'am.
So P and our unit circle are intersecting. And we know that when we're looking at the point of intersection, what do we do to the equations?
We equate, man.
Thank you. So meaning that let's find that P. We want this P. This P, we want it. This one, we want it. They say it's a point of intersection between y is equals to x and x squared plus y squared is equals to 1. Between the circle and that line. So when we equate it, we see, okay, if y is equals to x, meaning that where we see y, we substitute x. So this is x squared plus x squared is equals to 1. Therefore, this is 2x squared is equals to 1. Isn't that we're finding the point of intersection, guys?
Sorry, ma'am, can you repeat that?
Yeah, they're telling that the point P is the intersection of the straight of this line y is equals to x and the circle. And we said that when one point of intersection, we equate them, isn't it?
Yes.
So here, what are we going to do to find the point of intersection of these two equations? Because we have x squared and we don't have x, we have x squared. So what we can do is, you can take this equation and substitute it in here. So then this becomes x squared plus, where you see y, you put x. So this is x squared is equals to 1. 2x squared is equals to 1. Then x squared is equals to 1 over 2. Then x is equals to plus or minus the 1 over the square root of 2. Are we all together there, guys? Or I'm missing someone? Guys, why is it
So it's just like a simultaneous equation where you just take the y there, then you put the x, then you put it there, then you solve for the okay.
Yes, because remember, when you're finding the point of intersection, you are doing simultaneous equations. That's why they're emphasizing for you to do simultaneous equations in grade 10, so that when you get to grade 12, you are able to find the point of intersections. And I don't know if you guys knew that when you are doing in simultaneous equation, you are finding the point of intersection of the two graphs. That's simultaneous equation. Are we all together now?
Yes, ma'am.
So now x is equals to a positive 1 over root 2, or a x is equals to 1 over root 2. But because the point that we are looking for is in the first quadrant, and we know in the first quadrant x and y are positive, it means we'll use this one. Do you see that? Then we go back and substitute in here. In one of them, y is equals to x. In this equation, on this equation, I prefer this one, is easier because it says y is equals to x. And I got x, meaning that my y will also be what? My y will also be 1 over root 2. Are we all together?
Yes.
Meaning this point,
Yes, ma'am.
this point here
Yes,
is 1
ma'am.
over root 2 and 1 over root 2. Are we all together?
Yes.
Yes.
Yes,
Now,
ma'am.
don't be confused. 1 over root 2 is the same as root 2 over 2 and root 2 over 2. Are we all together? So meaning that the terminal point for pi over 4 is root 2 over 2 and root 2 over 2. Are you going to cram it, or are you going to understand it, or are you going to do all the step, or you want a shorter version of this thing?
I want both.
Okay.
Can we get what helps us understand it?
Okay, thank you. So this one, of deriving this one, I don't want you to derive it. Now, cramming it, I don't want you to cram it. I'll take you back to your grades so that we can be able to know our special angles by heart. Now, since the unit circle is symmetric with respect to the line y is equals to x, it follows that P lies on the line y is equals to x. So P is the point of intersection in the first quadrant, as we've shown, of the circle x squared plus y squared is equals to 1, and the line y is equals to x. So substitute x for y in the equation of the circle, we get this. This is what we calculated, and we found that our x is plus or minus 1 over root 2. Now, since P is in the first quadrant, therefore we take the positive 1, and since y is equals to x, we then substitute there. That's the terminal point determined by pi over 2 over 4 is equals to what? Root of 2 over 2, root of 2 over 2. Are we all together? Guys?
Yes, ma'am.
So now,
Yes, ma'am.
okay. Now they say similar methods can be used to determine the terminal points determined by t, which is pi over 6. What's pi over 6? What is pi over 6, guys?
30 degrees.
Thank you. And t is pi over 3. What is pi over 3?
60 degrees.
Degrees.
Okay. And then figure 6 gives the terminal points for some special values of t. Are you going to cram this table? Do you want to cram it?
Nope.
Do you want to understand it, or do you want to what? Or do you want to cram something simpler and use it to understand something? Yeah. What is our agreement here? We need to agree on something.
Me, I want
Something.
both. I don't know.
We want to
To
understand.
understand it.
To understand.
Understand
Yeah.
it.
So if we're going to understand, we need to leave our slides. Discharge. Okay, we're going to leave our slides for now. And understanding it means that we need more time to our classes. So there's something you did in high school, if you remember properly, or if you don't remember properly. Now, there's a relationship between a unit circle and trigonometric functions, right? And that relationship, I will not explain it now. We'll explain it later on, right? So now, that relationship says that if you, let's say, for example, if they say find the terminal point t, to find the terminal point p, x of y, determined by t, what you can do is then you can go and say p of cos of t, sine of t. Do you understand? And then you take and substitute t in there, it will give you the terminal points. Are we all together? Guys?
Yes, ma'am.
Yes. So meaning that,
Yes, ma'am.
for example, t is equals to pi over 4. So if we were to say find the terminal point, you could have also done like this and say, okay, the terminal point where cos of t will give me cos of t will give me the terminal point for what's this? The terminal value for the point x. I mean the terminal point. It will give me the x value of the terminal point, and sine of t will give me the y value of the turning point. So instead of doing what we were doing of saying x is equals to y is equals to x, x squared simultaneous equation, you could have also said, okay, fine, I want to find the terminal point. Therefore, I'll say cos of pi over 4 and sine of pi over 4. What do you get there in your calculator? I'm allowing to use a calculator today. What is cos pi over 4?
0.99.
You are getting 0.99.
Yeah.
Can someone help there?
Root 2 over 2.
Why are you getting
Root 2
0.99?
over 2.
Can you please help her why she's getting 0.99 and it's not correct? Is your calculator is in degrees then? You have to change it to radians. Did you fix that one? So here the answer is root 2 over 2. And here the answer will be what? Root 2 over 2.
over 2.
Do you see that this one was more easier compared to what we did?
Yes. Yes,
So
ma'am.
meaning that if they give you t and they want you to find the terminal point, you can go and substitute in cos t and sin t and get your answer. All together. Don't say I didn't
Yes,
plug you.
ma'am.
Yes,
No,
ma'am.
Thank
You
you.
plugged us.
Thank you.
Already question 1 is solved.
Thank you. So now, I don't want to just plug you. I want you to plug you mentally as well. So there is a relationship between, as I said, there is a relationship between the cos function and the trigonometric functions and the unit circle. Now, if we go back to our basic, let's start with our basic trigonometric function. Let's say we want to draw y is equals to sine of x, right? And we want to draw, let's say z is equals to cos of x, right? We know that the period, meaning that a complete period of a function like this, meaning a complete circle, let's say a complete circle. How can I put it? How do you say a complete period? Let's say, I want an example. Let's say when you're in the center and you have and a complete period is for you to run from the center and score the goal, right? So if you take the ball and score the goal, that's a complete period. Are you together? And then when you come back again and come and take the ball and score it again, those are 2 periods now. Are you all together? A complete cycle. Actually, let's say a complete cycle. Guys, am I confusing you or am I confusing myself as well? Guys.
You're confusing me, man. I'm confused. Okay. A complete period of a sine graph looks like this. One complete period looks like this. Yes. Right? Now let's leave the soccer because I don't know soccer. I don't know why I was using it. Now a complete period of cos looks like this. Are we together there? Don't cram it, I'll explain it. Are we together?
Yes, ma'am.
Yes, ma'am.
Now, if they say draw 2 periods of sine, it means that you start with the first one that looks like this, That's the first period. And then because they say 2, you draw another one. Like that. Does it make sense? Because then this is exactly same as this. So this is the first period and this is the second period. I'm not sure if I'm using the right term though. Are we together there? Now a complete period of course looks like this. If they say draw another one, it means you're going to join here and draw, and it will look like this. So it means you have 2 periods of what? Of course here. Are we all together there? Yes or no? Okay. I see I only find one yes. Now,
Yes,
we know
ma'am.
that the period for what? For sine is 360 degrees. In our case, we'll call it 2 pi. Ne? And a complete period for cos is what? 360. For this one, not the one that is like 2 cos of x plus 2 plus 3 and whatever. Only sine, like sine and cos, not a shifted cos and sine. It's 360, right? And we know that for us to be able to draw this graph, we'll say 360 period divided by 4. We get what? We get 90 degrees. Are we all together? Because we want to draw the graph. So we then go to our Cartesian plane. This one will indicate the interval, meaning we start at 0, come to 90 degrees. Ne? After that, what is 90 degrees plus 90? That's 180 degrees. What is 180? That is 270 degrees. And then 360 degrees.
360 degrees.
Are we all together, guys?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now, sine at 0 is always 0. Are we all together?
Yes.
So sine starts at 0. Sine starts at 0, goes to 1 at 90, and then goes to 0 at 180, and goes to 1 at 270, and goes to 0 at 360. Do you see now? This is one complete period of sine function. This is -1. Are we all together there?
Yes, ma'am.
Yes.
This
Yes,
is
ma'am.
y is equals to sine of x. So always remember that because we are coming back to trigonometric function. Now, let's go to cos. Cos starts at 1. That's here. Goes to 90. When it comes to 90, it will say 0. And then at 180, it will say 1. And then at 270, it says 0. And then at 360, it says 1. So cos is more like a really opposite of sine. Do you see that?
Yes, ma'am.
So this is y is equals to cos of x. Are we all together?
Yes, ma'am.
So if we say that, if we say for the terminal points, the pink line gives us our y values, and the blue line gives us our x values. Right? Look at this. We said that the y gives us our y values, isn't it? And the x gives us, I mean, sine gives us our y values and cos gives us our x values, right?
Mm-hmm.
Look at this.
Yes,
This,
ma'am.
if you were to form a point, what point is this? This is 1 and 0. Do you see that? Guys, are we together?
We are
Yes, ma'am.
together,
Yes,
ma'am.
ma'am.
This is 0 and 1. This is -1 and 0. This is 0 and -1. Do you see the relationship?
Yes.
This is the relationship towards the unit circle. Are we all together there?
Yes, ma'am.
So sine,
Yes.
what is sine 90 degrees? Guys,
-1.
1.
thank you. I wanted to remember. I want you to know it by heart. What is sine pi? Sine pi.
180 degrees.
Yes. What is sine pi? What's the answer of sine pi?
-1 and
0.
0.
0.
Okay. What is cos of 2 pi? Guys, why is it
1
taking
0.
1
cos of 2
0.
pi is 1. Remember, 90 is pi over 2. This is what? This is pi. This is 3 pi over 2. And this is 2 pi. What is cos pi over 2?
90.
What is cos pi over 2?
0 minus 1.
What is
90.
cos pi over 2?
Pi over 2. Wait.
0.
Thank you.
What
Look
is
at the
there?
graph. What is cos pi?
It's not 90.
Guys,
-1.
thank you.
-1.
Thank you. Look at this. Look at your graphs. I want you to sink in, because if we continue without sinking in, it's a problem. I told you that cos starts at pi at 1. When it comes to pi over 2, it's 0. When it comes to here, which is pi, it becomes -1. When it comes to 3 pi over 2, it becomes 0. When it comes to 2 pi, cos becomes what? Becomes 0. So what is sine 2 pi?
0.
0.
What is sine 3 pi over 2?
-1.
What is sine pi?
It's 0.
What is sine 0?
Pi.
It's 0.
Are we getting it, guys? Or I'm so...
I don't understand.
So, ma'am, if I may ask, so when you're using this graph, when you're asking about the cos and you're asking about the sine, are you asking on the cos, you're asking the x values, on sine, you're asking the y values?
No, I'm just asking.
Okay.
So the x and y value is only the unit circle.
Oh,
So
okay.
let's draw like this. Let's start like this. Remember, we said it will be 0. And now I'm going to radians. I think you now know what pi and 2 pi is, isn't it?
Yes.
Yes.
And 2 pi. So now sine always starts at 0. Then at 90, sine 90 is equals to 1. Then sine 180 is equals to 0. Then sine 270 is equals to -1. Sine 2 is equals to 0. Do you see that? So this is the graph of y is equals to sine of x. Now the graph of cos is this one here. Okay, let me draw it here. At 0, cos 0 is 1. Cos 90 is 0. Cos 180 is -1. Cos 270 is negative. I mean, it's 0. And then cos 2 pi is 1. So this is a graph of cos. Do you see that? Now, if I say sine 0, it means this. What happened? Where is sine at 0? What is the y value of sine at 0? It's 0. Do you see that? What is the y value at sine at 90? It's 1. What is the y value at sine at pi? It's negative 1.
0.
0. Thank you. What is the y value at sine 270? Is what?
Negative 1.
What is the
Negative
what is
1.
y value at sine 2 pi?
Is
0.
0.
Thank you. And I come back and say, okay, cos. What is cos of 0? What is the y value? Thank you. What is the y value at cos of 90?
Is
0.
0.
What is the y value at cos of 180?
Is
Negative
negative
1.
1.
What is the y
Negative
value
1.
at cos of 3 over 2, which is 270?
Is 0.
What is cos of 2 pi?
1.
1.
Do you understand it now?
Yes, ma'am.
Thank you. You have to understand it because your graphs will be there. Now, there's these triangles of special angles that you learned. There's this one, a right angle triangle. Do you remember those ones?
Yeah.
So here it was 30 degrees. Here it was 60 degrees. Ne? And then, ooh, yeah. And then this was 2. This was root of 3. And this was 1. And there was another one, which was derived from I think it was the isosceles triangle. So this is 45 degrees. This is 45 degrees. And this was 1, and this was root of 2. Do you remember this one? Guys?
Yes, ma'am, we do.
I want you to cramp these triangles. Ne? Are we all together?
Yes, ma'am. We are.
Thank you. Can we convert these angles into radians now? Because we are dealing with radians. Let's start with the first one. So the first one will be, help me please. 60 is what? What is 60?
Pi over 3.
Thank you. Pi over 3. Right? And then what is 30?
Pi over
3. Thank
Over
you.
6.
So we keep these ones the way they are. Okay? Then let's come to this one. We are changing these angles into degrees. So what is this one? It will be pi over
4. Pi over 4.
And this one will be pi over 4. This one will be 1 and 1 and square root of 2. So meaning that we are forgetting our grade 10 work. Now we are in radiances. Are we all together there?
Yes, ma'am. Yes, ma'am.
Yes.
Now, you remember Sokatoa?
Yes.
Let's write it. Sokatoa. What is sine? Sine is what?
Opposite
over hypotenuse.
And then cos is?
Adjacent.
Adjacent over
Hypotenuse.
Q. And then 10 was?
Opposite over adjacent.
Thank you. Are we all together?
Yes, ma'am.
Now, the unit circle.
Yes, ma'am.
Let's go back to a unit circle. We said the x value is what? Cos of something, isn't it? That's what we said, cos of t, right?
Yes.
And then what's this?
The y value is sine t.
Sine of t. Are we all together?
Yes, ma'am.
Yes,
So I want us to create something here. So here we have sine of t, ne? Here we have cos of t. And here we have tan of t. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Give me the special angles. You know your special angles. Let's start with, yeah, give me your special angles.
30.
It's what? It's
30.
It's not 30, it's what?
Pi over 6.
Thank you. It's pi over 6. Pi over 6. Another one?
Pi
Over
over
Pi over?
4.
3.
Pi over 4.
Thank you. Another one?
Over
Pi over
Pi
3.
over 3.
Thank you. Now let's find sine t. What is sine t? Sine t, we want sine of pi over 6. What is sine pi over 6? Where is pi over 6? Look at pi over 6, guys. What is sine pi over 6?
1 over 2.
30 degrees.
1 over 2.
It's 1 over?
2. 1 over 2.
Is it 1 over 2, guys?
Yes, ma'am.
No.
So we know that sine is opposite of hypotenuse, right? And let's go back if we forgot. We say something that is opposite is if I'm standing here and I draw a line like this, then this side is opposite to this angle. If I draw a line like this, then this side is opposite to this angle. If I draw a line like this, then this side is opposite to this angle. Are we all together?
Yes.
Yes or no?
Yes, ma'am.
Yes, ma'am.
Now, when we're talking about adjacent, we're talking about the side next to, which is not an hypotenuse, meaning that the side that is adjacent to pi over 6 is this one. The side that is adjacent to pi over 3 is this one, not the hypotenuse. Are we all together? We remember that one, right? Now,
Yes.
Sine of pi over 6, we go to pi over 6. Here's pi over 6. According to sine, it says opposite, meaning this side over here, of hypotenuse, which is 2. So that's 1 over 2. 1 over 2. Are we together there?
Yes.
Okay.
Mm.
Now let's do cos pi over 6. What is cos pi over 6?
Adjacent over hypotenuse.
So what will be the value?
1 over
1?
Square root of 3 over 2.
Yes.
Square
Yes,
root of?
that's adjacent over hypotenuse. Square root of 3 over 2.
Over 2.
I'm writing what you're saying.
Ma'am, sorry.
Yes.
Can I excuse myself for the rest of the class? I have to attend to some certain things.
Okay, no problem. As long as you come back later on and watch the video and make sure you understand, it's okay.
All right.
And then what is tan t? Give me the value for tan t.
1 over root 3.
1 over root 3.
Thank you. Yes, 1 over root 3.
Now, sine t, we are done with that one. Let's look at sine pi over 4. What is sine pi over 4? Look at where pi over 4 is in this triangle now. And this is also a right angle triangle.
1 over
square root.
1 over root 2.
1 over root 2. Thank you. So what is pi? What is cos pi over 4?
One over root 2.
What is 10 pi over 4?
1 over 2.
1
over 1.
Thank you.
1 over 1. 1 over 1. Oh.
So what is sine pi over 3?
Root 3 over 2.
Root 3 over root 2.
Root 3 over 2.
Guys, are you looking at the triangles, right? Not the calculator.
Yes.
Yeah, we're
Yes.
using special
Thank you.
Yes, ma'am.
So what is cos pi over 3?
1 over 2.
1 over?
1 over
1 over
2.
2.
And then what is 10 pi over 3?
Root 3.
Root 3.
Are we all together?
Yes,
Yes.
ma'am.
So let me copy this one. Okay, here's the screenshot. I'm copying this one because I need it. Come here. Got. Okay. Now, before that, okay, it's fine. Let's go back to the slides. I just want to, so there's sine, okay, there's 0 and pi over 2. We said sine 0 is what? Can someone remember? Sine 0 is what, according to the graph?
0.
And then cos 0 is what?
1.
It's 1. Thank you. And then we
1.
said sine
Is 1.
pi over 2 is equals to what?
It's 1.
And then cos pi over 2 was what?
Is 0.
0. Thank you. Now, remember we said the terminal point is x and y, which can be represented as cos of t and sine of t. Do you remember that?
Yes, ma'am.
So I want you to go and give me that table of the terminal points. This is t, and this is your terminal point x and y. So your t is 0, and then you have pi over 6, and then you have pi over 4, and then you have pi over 3, and then you have pi over 2. I want you to give me the terminal points there. T is equals to 0. It will be what and what? Can someone guess? From what
0
we
and
have
1.
found. Thank you. T is equals to 0. It will be what? Is it 0 and 1?
1 and 1.
1 and 0.
1 and 0.
Yes, because it's cos t, sine t. So cos 0 is what? Is 1, sine 0 is 0.
1 and 0, ma'am.
Thank you. What is the terminal point for pi over 6?
Root 3 over 2.
Thank you. It will be root 3 over 2 and?
Over 2 and 1 over 2.
1 over 2. What is the terminal point for pi over 4?
Root 2, root 2 over 2, and root 2 over 2.
Thank you. Which is the same as?
Root 2 over 2. Root 2 over 2.
So what is the terminal point for pi over 3?
Root 1 over 2. 1 over 3 over 2 over root and root 3 over 2.
What is the terminal point for pi over 6? Over 2, I mean, sorry.
0 and 1.
0 and 1.
0 and 1.
Okay, I cut the wrong thing. So what I'm trying to show you here is that we went and actually did this over here by understanding how we find the blocks. Okay, let me just show the slides because it's not cutting. This one, okay, I didn't copy it. It's still not showing, guys. This one over here. Do you see that? So let me put it here.
Yes.
Look at this. So it means the terminal point for we got 1 and 2 root 3 over, we got everything correctly. Do you see how you find the terminal points if you forget them?
Yes, ma'am.
Yes,
So
ma'am.
meaning
Yes, ma'am.
that you don't
Yes,
have to
ma'am.
go and cram this. What you need to do is just go and know these triangles. Yeah, I don't know where I put them. The triangles that we use, these ones, these two triangles. These two triangles are very important. That's what you need to go and know. Draw them, then they will help you to find this table over here. With the relationship that the terminal point, the x value of the terminal point is cos and the y value of the terminal point is sine. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Thank you. Now we can move on.
Yes.
Now they say find the terminal points determined by each given real numbers t. Can you be able to do that?
Yes.
Should I give you 5 minutes to try them, all of them, and then we
Yes,
come back and I
ma'am.
explain them? Okay.
Okay.
Did you find the first one?
Yes, ma'am.
So what did you get? What did you get as the terminal point?
Negative 1 over square root of 2.
1 over and 1 over root 2.
So you got the terminal point was
Root 2 over 2.
root 2 over 2, negative root 2 over 2,
Yes.
and
Negative root 2 over 2.
did you all get that one?
No, the first one is positive.
Did you all get that one?
Yes.
Yes, ma'am.
Ma'am.
Is there someone who
Yes,
doesn't
ma'am.
understand how we got it?
Ma'am, can you explain for me, please?
Okay. Now, okay, let's do this. Let me explain because there's still a lot of work and it looks like we were a bit slow today. I'll need all this and then I'll explain all of it. Okay. I hope I made a copy. Escape. Escape. I'll come here. Okay. So they want us to find the terminal point of these ones, right? Now, if we go back to our Cartesian plane, let's draw our Cartesian plane. Remember, we are moving along the unit circle. So we go and draw our Cartesian plane, and we're going to move along this unit circle over here. I haven't drawn it properly. Ish. Let me do this. Maybe it will be better like this. Now, we know that this is 0, né? And this is pi over 2. And this is pi. And this is 3 pi over 2. Can someone please mute there? Okay. Now, if I draw the first line when it comes to special angle, what does the first line represent? The distance from here to here. What does it represent, the first line? In special angles.
30.
Thank you. And 30 degrees is pi over 6, isn't it? And then the angle that's in between, what does it represent?
45.
Which
Pi
is
over
pi
4.
over 4. And then this one here represents what?
60, which is pi over 3.
Pi over 3. Do you see that? Same applies. This is the first quadrant, the second quadrant, the third, and the fourth. Same applies with this one. If you start from here, this one will represent a 30 degrees, but you don't write pi over 3, isn't it, guys? And then this one, so this will be 90 plus 30 degrees, which is around 120 degrees, but you don't write it as pi, you don't write it as 30 degrees. And then the second line here will represent the 45, and then this one represents the 60, and then comes to 90, like that. And even here, when you start here, it's the 30 degrees, and this one is the 45, and this one is the what? 60, and then comes to 90. Same applies here. You're starting here. So this will be some 30 degrees from here. This will be 45 degrees from here, which is pi over 4. And this will be 60 degrees from here, pi over 4. Even if you start here and go down, this will be 30 degrees, which is pi over 6, pi over 4, and pi over 3. Are we all together there, guys?
Yes.
Yes, ma'am.
Now, so they are saying that you're moving pi over 4. It means that you are moving from, we know it's 0 here, right? Where you start. This is negative pi over 6, and this is negative pi over 4, 4, and this is negative pi over 3. Now, because you are moving pi over 4, it means that you start from here and come here. Do you see that? Do you see that?
Yes, ma'am.
And we know
Yes,
that
ma'am.
pi over 4, what is the terminal? What is the, if you look at pi over 4, you use pi over 4. So what is the terminal point for pi over 4 according to what we have learned?
Root 2 over 2 and root 2 over 2.
Thank you. Root 2 over 2 and root 2 over 2. If you can't remember, you go and draw the pi over 4 triangle. Pi over 4 and pi over 4. And this is 90, this is 1, and this is root 2. And we know that this part represents the cos and this part represents the sine. So then you go and say, let's say you don't remember those things. And you know that cos is opposite over hypotenuse. So what is, adjacent over hypotenuse, which is this one, over hypotenuse. So then that is 1 over root 2. And then the sine is opposite, which is this one, over hypotenuse, which is 1 over root 2, which is just the same as root 2 over 2 and root 2 over 2, right? Now that you're done with the terminal point for pi over 2, we are looking for negative pi over 2. And negative pi over 2, where is it? In which quadrant is negative pi over 2? Negative pi over 4. In which quadrant? The fourth quadrant.
4.
And we know that the fourth quadrant, the x and the y values, the sign of the x value is what? Is positive, and the sign of the y value is negative. Do you see that?
Yes.
So meaning that this point now changes to, for t is equals to negative pi over 4, this point changes to, the y value is what? Positive. So we keep it the way it is, which is root 2 over 2. And then the y value is negative. So this is negative root 2 over 2. Does it make sense how I got it?
Yes.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So I need my second, that's the thing. So I'll just copy it. It's taking time to draw. As long as you understand the circle, it's much better. Okay, let's look at 3 pi over 4. 3 pi over 4. Which one are you going to use as which one are you going to start with as t? It will use as like a reference, some sort of a reference. Which one are you going to start with? T. Guys? Hello?
Pi.
Thank you. You're going to start with pi over 4 because there's pi over 4 here. Do you see that? So it means you start with pi over 4, right? You first find the I'm doing something that is in the next chapter, but it's fine. So you start with t, which is pi over 4, because here you're looking for 3 pi over 4. For the main fact that you're looking for 3 pi over 4, then you know that you're going to use that the points, they will be exactly the same points as pi over 4, except for the sign. Are we together there?
Yes, ma'am.
Yes,
So
ma'am.
meaning that we're looking for t is equals to 3 pi over 4. So meaning that the terminal point will be what? Will be root 2 over 2, root 2
Minus
over 2,
root 2 over 2.
right? Wait, the terminal point for pi over 4 is root 2 over 2. Okay, let me write it here. So the terminal point is root 2 over 2 and root 2 over 2. Are we together there? Guys,
Yes,
are
ma'am.
we together?
Yes,
So now
ma'am.
this
Yes.
of the over 4 and over 4, these terminal points will be the same except for the sign. How do we determine sign? Look at this. This is the same as 3 times pi over 4. Am I right?
Yes, ma'am.
So it means I
Yes,
have to
ma'am.
move how many pi over 4s?
3.
Thank you.
3.
Three,
So
three.
let's go.
Going
Let's
anti-clockwise.
look. Thank you. Anti-clockwise, because the sign is positive. Let's go and look. The first pi over 4, where is it? It's here.
The
Okay,
first
let me erase
quadrant.
it. Thank you. This is the first one. 1, isn't it?
Yes, ma'am.
Yes, ma'am.
The second one, what is pi over 4 plus pi over 4? That is, what is 45 plus 45? 90. It means I'm going to
90.
stand where? Here. That's the second one. Do you see that?
Yes.
Yeah.
Now, between line 1, 2, 3, if I move from where I am, where is the pi over 4?
Line 2.
Thank you. It means that the third one is here.
Yes.
So in which quadrant am I?
Second.
The
Second quadrant.
What do we know about the XY values in the second quadrant?
The x are negative and the
X
y
and
is
negative.
No,
So
the
then
X are positive and the
Negative. Why are positive?
X
X is negative.
Thank you. It means we're going to take this point and say for 3 over 4 negative root of 2 over 2 and root of 2 over 2. Make sense, guys?
Yes.
Yes, ma'am.
Yes, ma'am.
Do you see
Yes,
I'm not
ma'am.
using a calculator? Ne? I know you can use a calculator in your assignments because I won't see that you use the calculator. You come back with the negative root 2 over 2. You can check if you want and say cos of 3 pi over 2, cos of 3 pi over 4, and you see it's negative root 2 over 2. You see? Are we all together now?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Thank you.
Yes, ma'am.
Let's go back. So what I'll do is I want me to erase the green part. I'm very slow on this one because I know I want us to understand it. And once you understand it, then it becomes easier to go and redo your assignment properly. Okay, now t is equals to negative 5 over 6. What am I using? T is equals to what? From my special angles.
Pi over 6.
Over 6.
Thank you. So meaning I don't need this triangle, ne? So let's start there. So t is equals to pi over 6, right? So it means I need this triangle that has a pi over 6. If I remember very well, we said this is pi over 6, and this will be pi over 3, and this will be, can someone remind me? Here it will be what?
1.
What did we get?
1.
It's 1, ma'am.
1 and the square root of
1.
3. 1
It's 1.
is 1.
On the side opposite to pi over 3.
It's root 3, ma'am.
Yes. Always remember 3 root 3.
Yes.
Do you see that? And there's only 1 pi over 6. I always say that. So remember like that, right? Okay. So what do we know? What is the terminal point for this one? Pi over 6. Using the relationship of cos of t and sine of t. Use that relationship. It will help us a lot. So meaning that the terminal point of pi over 6 will be what?
1 over 2.
Cos is what? It's adjacent over hypotenuse, isn't it?
Yes. It's
So
1 over.
Huh?
1 over 2.
It's 1 over 2.
That is for sine. She wants cosine.
Or cos
It's
is
root
square root
3
of 3
over
over
2.
2. Cos.
And then sine?
It's 1 over 2.
1 over 2. So do you see how I find the terminal points, isn't it?
Yes, ma'am.
So I didn't cram that table. Okay, so what are we looking for? Let's go. and check. We know that because this one is negative 5 pi over 6, right? So we're looking at, hey, what just happened now? Okay, guys. I don't know what happened. Yeah, I don't know what happened. But remind me. Okay, what was the terminal point of? We know the terminal point was what? Was root 2 over, root 3, isn't it?
Root 3 over 2.
Over
Yes.
2
Yes, ma'am. Root 3.
and 1
I
out.
think the pen is. So root 3 over 2 and 1
1
over
1
2.
2.
So
1
we
over
know
2.
that the terminal, okay. So we know that our, oh, they moved up. Yeah, technology will drive you crazy. Okay, we know that here we are moving in an anti-clockwise direction because of the negative, right? Are you all together?
Yes.
Yes, ma'am.
And we know that the
Clockwise.
terminal point will be root
Clockwise,
3
ma'am.
over 2 and 1 over 2, but the signs will be the only one that is changing. Are you all together?
Yes.
And how many fives? How many? I already gave you an answer. How many times should I move on pi over 6?
5 times.
5 times.
5 times.
So 5 times in the clockwise direction. Okay. So you will tell me where to move, on the first dot or second dot on the third dot. I start here. Between these ones, which one? First, second, or third?
First.
Okay, 1. And then where
One.
do I move? That's the first move.
To the second, to the third.
Thank you. To the third, that is the second move. Where do I move again?
The one that follows. Pi
Which
over
one?
2. Next
Thank
one.
you. 3. Where do I
3.
move?
Next one.
Next
4.
one.
Where do I move?
The last one. The
Second
next one.
between, you jump that one and the other one that follows.
5.
Yes.
That's where negative 5 pi over 6. Now, if someone doesn't understand how we were moving, this is what we were moving. How we're moving. I don't know why. I know pi over 6 is 30. So I know from here. Okay, let me choose a different highlighter. I know from here to here it's 30, right? And 30 plus 30, I go to 60.
60.
And then 60 plus 30, I go to 90.
Okay.
Then 90 plus 30, I know from here, right? From 90 here to here, it's also 30. And then from 30 plus another 30, I come here, which is 60. So then I have moved 1, 2, 3, 4, and 5. It means I'm in quadrant number 3. And in quadrant number 3, the x and the y values are what? Both what?
Negative.
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 So meaning that we use that point. What was our point, Gonji? It was root 3 over 2 and 1 over 2. So meaning that for t is equals to negative 5 pi over 6, our terminal point will be negative root 3 over 2 and negative 1 over 2.
True.
Are we all together?
Yes, ma'am.
Thank you. Sorry about that.
Yes, ma'am.
Movements of the highlighter. So we go back to our slides. We need to move fast, really fast. I didn't know how long this was. So did we get there? They say let P be the terminal point determined by negative P and let Q be the terminal point determined by pi over 2. So we were calling it P and P. Sorry about that. Let's call the other one Q. So Q is the one that is pi over 4, isn't it? And then they use that one and say, okay, negative pi. So then our P was the one that we got. Do you see that it's the same one, root 2 over 2 and negative root 2 over 2?
Yes.
Okay.
Yes, ma'am.
Now they say let P be the point determined by 3 pi over 4. Let Q be the terminal. So we're supposed to say, okay, pi over 4, pi over 6, and pi over 3 are Q, and then P is this. So it's still fine as long as we're able to find it. So now this is what we got. and we were able to move and show that it was in the second quadrant, and this is what we got as well. Now this one as well, oh, this is nice. We're just moving now, moving very fast. And then this one, we also show that we are here, we understood each other, we were on the same page, and we said we are using pi over 6, which is like this, and we found that both of them are negative, and we got the final answer. You see how nice it is to when you understand. Are we together there, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Now the reference number. They say that from example 3 and 4, we see that to find the terminal point in any quadrant, we need only to know the corresponding terminal point in the first quadrant. Meaning that to find negative 5 pi over 6, we needed to know pi over 6. To find 7 pi over 4, we needed to know pi over 4. To find 16 pi over 3, we needed to know pi over 3. That's what they're saying. Are we all together?
Yes, ma'am.
yes, ma'am.
So now they say use the idea of reference numbers to help us find the terminal point. Now we're going to use what we call reference number. Let t be a real number. The reference number t associated with t is the shortest distance along the unit circle between the terminal point determined by the t and the x-axis. I'm sure there's a question that asks you about reference numbers, guys.
Yes. Yes, there's a question.
So meaning that the whole question, we are finishing the whole question 1 today.
Yes.
Good. So let's understand them there. So did you understand what the reference number is? Guys, did you understand what a reference number is? Okay, silence means you guys understood what the reference number is. Okay, I'll continue. No one said no, isn't it? No one said please explain. Everyone.
Can you explain it again, ma'am? Explain it again.
It says the reference, the real number t, the t, let t be a real number. That's the t we've been dealing with, right?
Yeah,
Now, yes. Now the reference number t dash, do you see it has a hat there? Associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Does it make sense? You want me to read it again or to explain it?
Elaborate it, please.
Explain it.
Explain, ma'am.
Okay. So they're saying, remember our circle. Let me see if I can find space. Remember our unit circle, which I do not draw nicely. So this is a unit circle, right? Isn't that we were moving along that unit circle using the distance t? Ne?
Yes.
And that
Yes.
t will get a point called the terminal point xy, right?
Yes.
So they say that if I get t, this t, and I move from here to there, and this is my p here, then the reference number t bar to t is the distance from this point. Okay, now what am I doing? Okay, I don't know what have I done. Okay, is the distance from this t to, and then now the color is yellow. I want so it's the distance from here, this point to that point, the shortest distance from that point to that point. That's t bar. Are we together, guys?
Yes.
Yes.
Now, if I move like this, and then my p is here, because of t1, let's call it t1, it means that the reference number, they say the reference number is the distance from the the shortest distance from the x-axis to the point t, meaning that I can't say from the reference number will be from here to here. I mean, from the point to here. Do you see that? Which one is the shortest distance? It's this point to the x-axis. Do you see that? So this is my t bar.
Okay.
If I am here, my P here determined by some value of T, then my shortest distance to the x-axis is this one, and not this one. Up to there. These x-axis. Are we together, guys?
Yes.
Yes, ma'am.
Yes.
So that's what we call the reference number. I don't want to say reference angle. It's called the reference number. So here they are showing, they say, figure 8 shows that to find the reference number T, it's helpful to know the quadrant in which the terminal point determined by T lies. You see, if it lies here, then this is the shortest distance. If it lies here, then this is the shortest distance. If it lies here, then this is the shortest distance. If it lies here, then that's the shortest distance. Are we all together there?
Yes, ma'am.
Now
Yes,
they say
ma'am.
if the terminal point lies in the first quadrant or in the first or in the fourth, where x is positive, we find that the reference number by moving along the unit circle to the positive x-axis. And then what are they saying now? Oh, I see what they're saying. Does it make sense?
No, ma'am.
So they're saying that if the terminal point lies in the first quadrant or in the second, it means that you have to go to the positive x-axis. That's where your terminal point is. Here, look at this. So if it lies here or here, it means you'll always approach the x-axis, the positive x-axis. That's what they're saying. If it lies here, the terminal point lies here or here, it will approach the negative x-axis.
Yes.
It almost got me there. Now they say find the reference number of each value of T. Let's see. Can you find the reference number? I'm giving you 2 minutes. We need to finish this section, guys. Can you find the reference number?
I think so.
Give me the reference number.
So you see, when we're looking for the points, we're counting, right? We're going towards the x-axis. So I think on the straight line it's 180, so that is pi. So I think we subtract pi. We say pi, then we subtract this one, 5 over pi, to get the t bar.
You're right. Do you all understand that part, guys?
Yes, ma'am.
No, ma'am. Can you please repeat?
Please repeat.
Is it that time when we were looking for minus pi over 6, when mem was counting, like it's on 30, it's on 60, it's on 90, it's on what, going clockwise, then we landed at 5 minus 5 pi over 6. So to make it a complete, we needed another pi over 6, so that we will land at 180. So instead of just counting like that, we just subtract. If it's like a whole one, say just pi, so that's going to be 6 pi over 6. Then you just subtract 5 pi over 6. Then we end up having pi over 6.
Does it make sense, guys?
Can you do it?
I'm not understanding, ma'am.
No.
I don't understand, ma'am.
No, we
So-
don't understand.
So the reference number, do you understand the reference number, how to find it, isn't it? What it is?
Yes.
Okay.
Yes.
So
Yes,
let's start there. Is our circle? What are we looking for? You see now, when I'm tired, I forgot easily. We're looking for pi over what? The reference number for what? 5 pi.
5 pi over 6.
Yes. So they're saying that we want to find the reference number. Now remember, it's 0, right? Pi over 2, pi. Now I'm no longer using degrees. 3 pi over 2 and 2 pi. Do you remember that one, isn't it? And then we had our unit circle like this. Do you remember? And we
Yes,
said inside
Yes.
our unit circle, there's always 3 lines of the special angle. The first one, the second one, and the third one. Even in every quadrant, the first one, the second one, and the third one. The first one, the second one, and the third one. I'm actually drawing it wrong. I'll show you the first one and the second one and the third one. How does these lines appear? They're actually drawn like this. When you draw it, they'll say the first one, as you saw in that one we had. The first one, and then they, yes, this is how they draw them. Not what I'm drawing, but at least like this. And then even this side, they say the first one, the second one, and the third one. That's how they draw them. So, but then still, if you draw them like this, they'll help us. So then here we know it's pi over 6. Then here it's pi over 4. And here we know it's pi over 3. So then what we do is, remember we said that the reference number is, we're going to move along the distance and find where p lies, right? So here, we're looking at 5 pi over 6. It means that we're going to move how many times? We're going to move with pi 5 times, pi over 6 5 times. Are we all together there?
Yes, ma'am.
So we know that pi over 6 is actually, where is our first pi over 6? Our first pi over 6 is here.
First quadrant.
On the first, and it's positive, so it's here. This is pi over 6, and pi over 6 is 30, right? So this is the first movement. And the second movement will be where?
At pi over 3.
Pi over.
That's 2. Where? Another one?
Pi over 2.
Pi over
3.
2.
Yes, and another one?
The first one.
4. Another one?
Pi over 6.
You skip that one and go to the other one.
The other one.
Do you see that, guys? Are we all together there?
Yes.
So this is where our terminal point is. Determined by t is equals to 5 pi over 6. Are we all together?
Yes, ma'am.
Now
Yes,
they're saying that the terminal point is the distance from the x-axis. Remember that we said that if you are in this quadrant, this one and this one, you will approach what? The negative x-axis, isn't it? It means you'll be here, right? So meaning that we want a distance from this point to hit this x-axis there. And how do we measure the distance? We know that here it's 180. So you then say the reference number is pi minus what t did it come here? It's that 5 pi over 6. Then our reference number is equals to what? Pi over 6.
Pi over 6.
Are we together, guys?
Yes, ma'am, we are.
Now it makes sense.
Yes,
né?
ma'am.
Okay, let's move back. Let's do pi over 7 quickly. So I draw that round of mine, and I know this is what? Pi over 6. This is pi over 4. And this is pi over 3. And then 0, I have pi over 2, pi, 3 pi over 2, and 2 pi. Can someone try it while I'm drawing the lines? 1, 2, 3. 1, 2, 3. 1, 2, 3. Can someone try? What will be this one?
We're gonna move starting from pi over 4.
Yes. Was here?
Yes.
1. Then I go
So,
to?
Pi over 2.
Pi over 2.
Let him do it. Sorry, let him do it. I just want to hear from the guys. Yes, 2. And then you go to?
And skip that one, you go to another one.
Yes. 3.
It's 3. Skip
Yes.
that and you go to another one. It's 4.
Okay. 4 here. Yes.
You skip and go.
There you go. 5. And then?
Skip and go. Another
6.
1. 3 pi 2, yeah. And you skip and go 7.
7. I'm here. So the distance will be from which way?
From that, the last one to the positive x, because it's the first quadrant, the fourth quadrant is positive.
Thank you. So meaning the shortest distance, my reference number will be from here to here, isn't it?
Pi over 4.
Thank you. So it means that it will be what? Reference number will be what?
Pi minus 7 pi over 4, which is pi over 4.
Is it pi?
It's 2 pi.
2
pi. Because this line is 2 pi minus
Pi.
7 pi over 4, which is equals to what?
Pi over 4.
Make sense, guys?
Yes, ma'am.
Okay, let's move to the next reference number. I think we're covering question 1, if I'm not mistaken, the whole question 1 today, which is good. Okay, let's move to the next one. What do you think about the next one? Next one. While I'm drawing, think about the next one while I'm drawing. Guys? How am I moving here?
Which one is
Clockwise.
clockwise? The negative.
Okay, so where am I starting?
From
Here.
pi over 3.
Then I go to? So let me label them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm labeling the lines. Which line am I going to? Guys, which line am I going to? Hello? Guys, is my network not working? Or am I
It
talking?
is, ma'am.
It's working.
Just trying to figure out which one is this. 6 is this one or the other one. Just trying to figure out.
What is pi over 6? Let's start. What is pi over 3? Let's start there.
Pi over 3 is 60. So we are starting at 3.
60.
At number
There
3.
There we go. So how many
3.
movements do we need?
We need
2.
2.
Thank
So
you.
one that follows is at what?
So we are here. We move from here. Now we are here. Where do we go?
We go to number 5.
5.
Thank you. We go to number 5. So the shortest distance will be from here to here. Do you see that?
Yes, ma'am.
So then our reference number will be what?
Pi minus 3 to pi.
There we go. So the answer will be what?
Pi over 3.
Are we all together? Are we all together with reference numbers, guys?
Yes, ma'am.
Yes, ma'am.
And then D. What is D? What is D, guys? You don't know?
I don't know. Do we have to convert like maybe pi is 3.14, then minus that? I'm not sure.
Okay, find where 5.8 is. Say 2 pi. Go and say 2 pi in the calculator. What is 2 pi in the calculator?
It's 6.2.
So it's
6.2.
then it means that
6.28.
if you move around, you move to 6.2. So it means 5.8 is where? Where do you think 5.8 is? In which quadrant?
In the fourth quadrant.
Fourth quadrant.
There we go. So it's in the fourth quadrant. So meaning that we have to go towards 260. I mean 2 pi. So it means it will be what? The reference number will be 2 pi minus 5.8. So that is equals to, if you say 2 pi minus 5.8, it will be 0, 0,
48.
0.8.
0.
Obviously, this one won't be in the exam. How is it? Are we okay with reference numbers now?
Yes.
So we're just on this G, we're just using the same logic we're using on A, B, and C.
Yes, because you're moving on the unit circle.
Okay, I get it.
Or you're always on the unit circle. And if you say 5 pi over 6, you see it will give you a value 2 comma something, 1 comma something as well. Do you see that? Because pi is a number, isn't it?
Yes,
so it gives
yes.
1 comma something, 2 comma something, whatever comma something. Yes. So let's see, we did find that our reference number is pi over 6 for the first one. The second one, we found that it was what? I can't see here. We did find that it was pi over 4. Ne? And then the third one, we found that it was pi over 3. Guys, did we find that, or me? I'm just saying what I see here. Eh?
We did, ma'am.
We did.
Thank
Yes,
you.
we did.
Thank you. And the last one we found that it's 4.8. So meaning that, so now the reference number, as we said, it's pi over minus that, and that is pi over 6, and then that's that, and that is pi over 4, and then that's that, and that is pi over 2, and that's that, and that's pi over 3, and then done with that. Now, they're saying using reference number to find the terminal point. Find the terminal point P. To find the terminal point P, determined by any value of T, we use the following steps. Now, we are using the reference number now. Isn't that you know how to find the reference number?
Yes.
We are confident. So they say to find the reference number, what am I saying? Yeah, my brain is saying something else. We'll take a break before the second session. Using reference numbers to find terminal points. To find the terminal point P determined by any value of T, we use the following step. The first one is find the reference number T. We know how to find that one. Then find the terminal point Q. Then determined by T. Find the terminal point Q determined by T. The terminal point determined by T is plus or minus those values where the signs are chosen according to the quadrant in which this terminal point lies. I think I might have shown you how to do this, guys, but let's just do it. Ne? Does it make sense what they're saying?
Let's do it now.
Yes, just finished doing that. Yeah.
I
Because
might have
changing the sign according to the quadrants. Yeah.
Okay, so what will happen? Remember, we found like pi over 4. Then we know the terminal points for pi over 4, right? And then after that, we then say, okay, fine, let's go and find where this point lies. And then after that, we then say, oh, it lies in the fourth quadrant. So it means that in the fourth quadrant, the x value is positive, the y value is negative. That's what we're doing basically now. So now they say find the terminal point determined by each row number. I think we did find the terminal point for this one, right?
Yes.
So we know that the terminal point here is what? Pi over 6, isn't it? Guys?
Yes, ma'am.
Yes,
We know
ma'am.
that, no. We are using the reference number. Let me see these values. I just want to see. It's the same values that we did here. Okay, I'm going to come here. The reason why I'm coming here, I want us to save time because these are the same values, if I'm not mistaken, of what they're asking us. Do you see that?
Yes, ma'am.
So they're telling us here, we are actually finding the terminal point using the reference number. Meaning that the first part, we found that the reference number here, T bar, is equals to pi over 6 for A, right?
Yes, ma'am.
Right? And then we go and find, we know the terminal point, let's call it Q because they like calling it Q, right? The terminal point of pi over 6, what is the terminal point of pi over 6? If you remember nicely. It was root 3 over 2 and 1 over 2, isn't it?
Yes, ma'am.
So we are using
Yes, ma'am.
this one is the reference number, which is pi over 6. We found that it's this one. But for us to find the terminal point of this value here, it means that now we need to go and say, where does this point lie? It lies in the
Third quadrant.
third quadrant, meaning that we know that our x value in the third quadrant is negative. So it's root 3 over 2 and 1 over 2. Are we all together there?
Yes.
Yes.
Now,
Yes, ma'am.
number B, it's the same value. So they say find the terminal point. We're answering that example that says find the terminal point using the reference number. So they gave you this. We go and find the reference number, and we found that our reference number is what? Is pi over 4. So then we found that our T bar is equals to pi over 4. So then we go and say Q. What are the values? What is the terminal point for pi over 4? We know that that's root 2 over 2 and root 2 over 2.
Over 2 over 2.
Right? Now, we then go and check the position where we landed. Do you see that we landed in the fourth quadrant? Now, in the fourth quadrant, we know that our y value is negative and our x value is positive, meaning the terminal point for this one here, it will be what? Root 2 over 2, negative root 2 over 2. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Okay?
Yeah.
Again, we are answering the question of find the terminal point using the reference number. So the first step is find the reference number for C. So we found that the reference number, which is T bar for C, we found it that was pi over 3. That was the reference. And then we say, okay, Q, the reference, what is pi over 3? We know pi over 3 is 1 over 2 and root 3 over 2. Please check that one. We can always check in the table. There. Pi over 3 is 1 over 2 and root 3 over 3 over 2. So we are correct. Where are we? There we go. Right? So now we then say, okay, fine. Where does the point determined by this lie? So we go and check. It actually lies in the third quadrant. So this point is here, meaning that the x and the y are both negative. So meaning that the terminal point determined by this, we call it P, will be negative 1 over 2 and root of 3 over 2, which will also be negative. Are we all together there now?
Yes,
We are
ma'am.
together, ma'am.
Yes, ma'am.
So meaning that we have answered this question where it says find the terminal point determined by each real number, T, right, using the reference number. So they say in reference number associated with these values at T. So it's those ones that we found. Then they say we found that the reference number is pi over 6, which then determines the point root 3 over 2 and 1 over 2. This means since the terminal point determined by T is in the second quadrant, its x value is negative and its y value is positive. So that's what we got. Same, they're applying here that the reference number we found was pi over 4, which determines that it's root 2 over 2, root 2 over 2. And then we go and determine the quadrant, which is the fourth quadrant. It means that the y value of the fourth quadrant will be negative. So then this will just be the negative there. There we go. And then they say the reference number, we found it that it's pi over 3, and then we know that pi over 3 gives us this one over here. But now where does the point lie? Where does the point lie? And we found that the point lies in the third quadrant, and we know that in the third quadrant, both of them are negative. So this will be negative, this will be negative, and this is what we got. Next slide. Now they say, okay, this is something different. Do you all understand now? Guys, are we together?
Yes, ma'am.
We are, ma'am.
So
We are
now
together.
since the circumference of the unit circle is 2 pi, the terminal point determined by t is the same as the terminal point determined by t plus 2 pi and t minus 2 pi. Is that clear? Yes or no?
Not really. Explain.
So they're saying that if you have t, ne? Let's say t is pi over 2, ne? Are we together, guys?
Yes, ma'am.
Yes.
Yes, ma'am.
They say that, okay, let's call it pi over 4 because now I know it by heart. T is equals to pi over 4. We know the terminal point is what? Root 2 over 2, isn't it? Root 2 over 2, right?
Yes.
So they are saying that because the circumference of the unit circle is 2 pi, ne? Then the terminal point, which will be given by t, this t, is exactly the same as t is equals to pi over 4 plus 2 pi, and t is equals to pi over 4 minus 2 pi. Does it make sense?
Yes, ma'am. Like
So
we're
for
doing
example, what is 4 pi over 2? I mean, what am I saying now? What is pi over 4 plus 2 pi? So this will be 8. This will be 9 over 4. And then this will be negative, should be negative
7 over 4.
negative 7 over 4. Thank you. So meaning that if you go in your calculator and say cos of 9 over 4, you'll get root 2, and then sine of 9 over 4, you'll get root 2. And if you say cos of negative 7 over 4, you get root 2 over 2, and then sine of negative 4, you get root 2 over 4 over 2. So they are saying that t, if t is equals to pi over 2, for example, then the terminal point for t of pi over 2 is the same as the terminal point for pi over 2 plus 2 pi is also the same as the one for pi over 2 minus 2 pi because of its circumference. Makes sense now. Does it make sense now, guys?
Yes, ma'am, it does.
Yes, ma'am.
So now they say in general, we can add or subtract any 2 pi, subtract 2 pi any number of times without changing the terminal point determined by t. So we use this observation in the next example to find the terminal points for a large value of t. Do you see the importance, guys? Do you see the importance, or is it only me seeing the importance of it?
We see it.
Okay. One person is seeing it.
So when you're given like an angle that is more, I
Not
can
the
just use
angle.
it.
Let's call it a distance.
Okay. Distance, sorry, yeah.
If you are given the
So the distance of like a bigger number or a smaller number, I can just use to subtract like the distance t and pi or 2 pi to get what I'm looking for.
that's how you can use it. Now they say find the terminal point determined by 29 pi over 6. Do you see that you can't, at some point, you will forget where you are if you use what we were using? Do you see that? Guys? Do you see what I'm talking
Yes.
about? Because there
Yes.
it was easy because we only had 5 movements and we're like, okay, we move 1, 2, 3. But imagine 29 times. You might end up fainting and then say, Ish, I don't know where I am. So they're saying to you, you can then, because it's big, why don't you just keep on subtracting 2 pi until you get to a smaller one? Because this relationship is explaining that this is the same as that. So you can just subtract 2 pi. So meaning you say t is equals to, because 2 until you can't move 29 times. How many 30 degrees 29 times? So you just say 29 pi over 6 minus 2 pi. What do you get? Guys?
10 over 6.
Hmm?
17 pi over 6.
Do you see you see it's still a big number. Then subtract another 2 pi. What do you get?
5 over
5
6.
pi over 6.
You get what?
5 pi over 6.
5 pi over 6.
5 pi over 6.
What is the terminal point for 5 pi over 6?
Pi over 6.
What is the terminal point?
So the terminal
We did 5 pi over 6, guys. What is the terminal point?
Negative
What is
root
the terminal
3
point?
over
3
2.
over
It's
2 and 1
minus root
over
3
2.
over 2 and 1 over 2.
So root 3 over 2 and 1 over 2. Are the signs correct as well?
Minus root 3.
Okay, here they're just saying they added instead. And they showed you that if you add this, you get this, and then you get that. We see that the terminal point for t is the same as that of the, so meaning that the terminal point for 29 pi over 6 is the same as the one for t is equals to 5 pi over 6. That's what they're saying with that relationship of separating 2 pi or adding 2 pi. There we go. And then we are done with this session. And then do I have any questions before I stop the recording? If it was recorded. Any questions? Guys?
I don't have.
So it means it's clear.
I don't know. Yes.
Okay. I'm glad it's clear. So we can then go and stop the recording. So we can go and do assignment question 1.